Ever wondered how different software systems are structured? The answer lies in the realm of software architecture, a vast and intriguing field that offers different approaches to system design. Each approach carries its own set of benefits and trade-offs, essentially offering a unique take on how to build software systems. Today we dive into the fascinating world of software architecture, exploring some of the most common approaches. First on the list is monolithic architecture. This approach views a software system as a single, unified entity. All components are tightly integrated and deployed together. While it's simple and straightforward, it can lead to systems that are difficult to maintain and scale due to their tightly coupled nature. Next, we have layered architecture. This approach organizes the system into distinct layers, such as presentation, application, domain, and data access layers. This separation of concerns helps manage complexity, but it can also lead to code duplication and a high degree of coupling between layers. Microservices architecture, on the other hand, decomposes the system into small independent services. These services can be developed, deployed, and scaled independently, often communicating via lightweight protocols like HTTP. While this approach promotes scalability and flexibility, it also introduces complexities in coordination and data consistency. Then, there's event-driven architecture. This approach emphasizes the production, detection, consumption, and reaction to events. It promotes loose coupling and scalability, but requires a robust infrastructure to handle and process events. Service-oriented architecture, or SOA, builds the system as a collection of loosely coupled, interoperable services that communicate via standardized protocols. It offers flexibility and interoperability, but can also lead to performance overhead due to the use of heavy protocols. Hexagonal architecture, also known as ports and adapters, separates application core logic from external concerns like databases, UIs, and frameworks. It promotes flexibility and portability, but can be overkill for simple applications. Clean architecture emphasizes separation of concerns and dependency inversion. It organizes the system into concentric circles of responsibility, with the innermost circle containing the most critical business logic. While it promotes testability and maintainability, it can be complex to implement. Domain-driven design, or DDD, focuses on understanding and modeling the domain of the application. This often results in a layered architecture with a rich domain model. It promotes a deep understanding of the business, but can be difficult to apply in practice. Event sourcing and CQRS use separate models for reading and writing data. Event sourcing captures all changes to application state as a sequence of events. This approach promotes scalability and auditability, but can lead to complexity in managing and replaying events. Finally, cloud-native architecture leverages cloud computing principles and services to build scalable, resilient, and highly available systems. It promotes scalability and resilience, but requires a deep understanding of cloud services and principles. In conclusion, software architecture is not a one-size-fits-all discipline. It offers a plethora of approaches, each with its own benefits and trade-offs. The choice of architecture depends on a multitude of factors, including the technology, domain, and organizational preferences. So the next time you marvel at a software system, remember the intricate architectural decisions that went into building it.